Okay, so Assalamualaikum and hi semua. So today we are going to learn about hybridization theory. Okay, so this hybridization theory actually related to valence bond theory that we have learned in the previous video. So why do we need to learn hybridization theory kalau dah berkaitan dengan valence bond theory? Kenapa tak guna aja valence bond theory tu? Okay, so di sini sebenarnya valence bond theory tu ada kelemahan dia. Okay, so sebelum saya cerita pasal weakness of valence bond theory, kita recap balik apa function valence bond theory. Okay, so valence bond theory adalah satu teori yang able to explain ataupun to show the covalent bond between atoms, and dia bukan sahaja boleh show bonding between atom, dia boleh specifically show yang mana sigma bond, yang mana pi bond, and macam mana sigma bond and pi bond tu terhasil. Okay, so let us look at the weakness of valence bond theory. So valence bond theory, for this one saya akan guna example CH4. So this is the Lewis structure for CH4, and then for valence bond theory we will need dia punya valence electronic configuration. Tapi in exam, let's say lah kita tak tahu what is the valence electronic configuration, what we can do adalah use the number of proton. Since dia carbon neutral, so dia adalah bilangan proton dan elektron dia sama. So the electronic configuration yang penuh is 1s2, 2s2n, 2p2. And we can rule out that the valence electronic configuration is 2s2 and 2p2. So from here we can write this in the form of orbital diagram. Okay, so 2s2, 2p2. Okay, and for hydrogen, simple, just 1s and then 1 electron. Okay, so from this valence electronic configuration, there are 2 unpaired electron. Okay, so over here, this one and this one, we call it as unpaired electrons. Okay, so there are 2 unpaired electron, so that means they can form 2 bonds. Okay, so tapi kita tengok balik, our CH4 molecule ada 1, 2, 3, 4 bonding. Okay, tapi kita hanya ada 2 unpaired, that means we can only form 2 bonds. Okay, so this is the reason why we need to learn hybridization. Sebab kalau ikut valence bond theory, kita tak boleh form CH4, kita hanya boleh form CH2. Sedangkan CH4 ni memang wujud. Okay, so to explain the presence of CH4, we need to use hybridization theory. Tapi bukan CH4 je, sebenarnya banyak lagi molekul lain yang tidak boleh di-explain oleh valence bond theory. Okay, so you can read the notes over here, exactly the same as I explained to you. Okay, so let us learn about hybridization theory. Okay, so hybridization theory is the process of mixing together 2 or more atomic orbitals that have similar energy or same quantum number is called hybridization. Okay, so hybridization macam kamu selalu dengar lah, kereta hybrid. So itu antara contoh hybrid lah. Hybrid means we mix 2 benda, okay, to produce benda yang baru lah. Okay, and macam kalau kereta hybrid tu, maksudnya kereta tu ada kuasa elektrik, mungkin ada kuasa minyak juga. Okay, so 2 at the same time. Okay, so this hybridization theory sama lah lebih kurang. Kita akan mix 2 or more atomic orbital. Okay, kita akan mix 2 or more orbital yang ada same energy. That means kalau n equal to 2, n equal to 2 lah. Kalau n equal to 3, semua 3 lah. Okay, and then when we mix together, itulah proses yang kita panggil hybridization. But when we mix the 2 or more atomic orbital together, dia akan produce new atomic orbital. Okay, dan atomic orbital tu kita akan panggil dia hybrid orbital. Okay. Okay, so let us look at this example to help us understand hybridization. Okay, so this orbital diagram is for carbon, 1s2, 2s2, 2p2. Okay, so 2s have higher energy than 1s disebabkan dia punya principal quantum number is higher than 1. Okay, and then 2p higher in energy than 2s. Okay, so from this electronic configuration, we know that there are 2 unpaired electron. That means carbon can only form 2 bonding. Okay, but that is not what happened. Carbon should be able to form 4 bonds. Okay, so kita nak tengoklah macam mana hybridization boleh explain ability of carbon to form 4 bonding. Okay, so for 2s, okay, so there ada this pair of electron, and then one of these electron is excited to this 2p orbital. Okay, and up, this is the result. Okay, so 2s become have 1 electron only, and 2p have 1 electron each. Okay, so now this valence electronic configuration dah ada 1, 2, 3, 4 unpaired electron. That means it can form 4 bonds. Okay, tapi this is not hybridization yet. Sebab tadi kita kata hybridization is a process of mixing 2 or more atomic orbital. So, we are going to mix 2s orbital with 3 2p orbitals. Okay, so end up when we mix them together, we will form 4 new hybrid orbital. And this hybrid orbital is called sp3 hybrid orbital. Okay, so kenapa sp3? Sebab tadi kita mix 1 2s orbital, 3 2p orbital. So, that's why we form sp3 hybrid orbital. Okay, so this 1s, kita biarkan dia je sebab the one that is responsible for bonding adalah valence electronic configuration. Okay, so that is how we form sp3 hybrid orbital. Next, we want to see macam mana pula bentuk sp3 hybrid orbital. Kalau valence bond theory, simple. Kita dah tahu 2p ataupun p orbital, the shape is dumbbell. S orbital is spherical. So, kalau sp3, shape dia macam mana? So, for sp3, actually what happened here adalah kita mixkan 1s orbital ataupun 2s orbital with 3p orbitals here. Okay, so dia punya campuran dia akan jadi kita campur 1 s orbital dengan 3 p orbital. So end up dia akan jadi bentuk yang macam sebelah ni. Okay, ada 4 sp3 orbital. Okay, so ini sp3 orbital, this is also sp3, sp3, sp3. So as you can see, shape dia separuh macam dumbbell, separuh lagi macam kecil je kat sini. Okay, and these atomic orbitals, this hybrid orbital will align themselves to be as far apart as possible so that they can minimize the repulsion. Okay, so yang saya sebut tadi itu adalah VSE PR. So maksudnya this sp3 hybrid orbital, dia akan susun diri dia untuk duduk jauh antara satu sama lain so that dia boleh kurangkan repulsion antara satu sama lain. End up, this sp3 hybrid orbital will form a tetrahedral shape like this. Okay, tapi kenapa tak nampak pun? Kenapa yang bulat-bulat kecil ni tak nampak pun? Okay, yang bulat-bulat kecil tu sebenarnya ada. You can see from here, ada, tapi dia macam terlindung macam ni. Ini yang besar, ini yang kecil. Okay, so bila dia terlindung, usually we tend to draw yang besar ni je lah. Kita tak draw yang kecil tu. Okay, so and for this one, dia punya ni dekat sini. So dia terlindung lah. So that's why kita tak nampak. Tapi the arrangement, we can see this arrangement looks like tetrahedral arrangement. Okay, but that is for sp3 sahaja. Banyak lagi type of orbital yang lain. So let us look here in your notes. Okay, so as you can see, there are 5 common type of hybrid orbital. Ada 5. Okay, so let's say if we mix 1 s orbital and 1 p orbital, the hybrid orbital akan jadi sp hybrid orbital. Tapi kalau kita mix 1 s orbital dengan 2 p orbital, kita akan jadi sp2 Okay. So, kalau kita mixkan 1s orbital dengan 3p orbital yang macam tadi, so we will form sp3 hybrid orbital. And next one, if we mix 1s orbital with 3p orbital and 1d orbital, so we will form sp3d orbital. Okay, so d over here is actually d1 lah, tapi kita tak tulis lah. Okay, and then next one, if we mix 1s orbital with 3p orbital and 2d orbital, kita akan form sp3d2. Okay, so saya tahu mesti ada yang nak tanya, kenapa tak ada sp4 miss? Kenapa tak ada sp4, sp5, sp6? Okay, so let us recall back what we have learned in chapter 2. Okay, so kita tahu dalam s orbital memang ada satu je orbital dalam tu kan. Dalam 1s ada satu je orbital. Kalau 2s pun memang ada satu je orbital. Okay, so memang s always 1. But kalau untuk p orbital pula memang ada 3 je dalam tu kan. For example, kita ada 2p. Ada 2px, 2py, 2pz. Kalau 3p pun sama. Kita ada 3px, 3py, 3pz. Kita mana ada 4 orbital. Kita hanya ada 3 orbital for 2p. Okay, so that's why for this hybrid orbital, the maximum is sp3. There is no sp4, sp5, sp6, tak wujud. Okay. Alright, and for d orbital, okay, d orbital we know that, for example, 3d, we have up until 5 orbital for 3d. Okay, 1, 2, 3, 4, 5. So, tapi dekat sini kita hanya belajar sampai sp3 D2, that means 1 s orbital, 3 p orbital and 2 d orbital sahaja yang kita akan mix together. Okay. Alright, and then next, let us continue with this one. So, this hybrid orbital, okay, sp, sp2, sp3, sp3d and sp3d2 will arrange themselves to be as far apart as possible to minimize the repulsion. So, as a result, this sp hybrid also have shape. Okay, dia pun ada shape dia tersendiri. Okay, so for example tadi kita tengok sp3 hybrid, which is this one. sp3 hybrid adalah dia akan ada tetrahedral shape. Okay, so kalau dia ada lone pair dia akan jadi trigonal pyramidal. Kalau dia ada dua lone pair dia akan jadi V shape or band. Okay, so kalau sp pula, since dia ada 2 pairs, 2 electron pair, that means shape dia hanyalah linear. Kalau sp2 dia ada 3 electron pair, so dia akan jadi trigonal planar kalau without lone pair. Kalau ada 1 lone pair, dia akan jadi V shape or band. And sp3d shape dia trigonal bipyramidal sebab dia ada 5 electron pair and so on lah. Kalau dia ada 1 lone pair, dia jadi seesaw, 2 lone pair jadi linear, jadi T-shape and 3 lone pair jadi linear. Okay. So, for sp3d2, dia adalah 6 electron pair. Kalau dia adalah octahedral. Okay. That means dia tak ada lone pair. Tapi kalau square pyramidal, 1 lone pair. Square planar, 2 lone pair and so on. Okay. Alright. So, that is introduction to hybridization.